What's going on, everybody? Welcome back to another example video with linear systems. This video will be a little bit different because we're not going to do much work. This is going to be just kind of think about it. I want to say conceptually, but more like kind of conceptually, but without just the numbers. So in terms of variables, so this one is going to be pretty much an intro on how to deal with defective eigenvalues and how we will write the general solution. The general solution before we actually get into doing the actual work. So in this example, we are given a 6x6 matrix that it is called A, and it has two multiplicity 3 eigenvalues, lambda 1 being -2 and lambda 2 is equal to 3 with defects 1 and 2 respectively, and is asking us to write the general solution. So let's dissect this a little bit more. So we have a 6x6 matrix, so that means there can be 6 eigenvalues, but we are only given 2, each of them having a multiplicity of 3. That makes sense. 3 plus 3 is equal to 6, so there's going to be 6 eigenvectors. 2 of them are going to be, not 2 of them, 3 of them is going to be for lambda being -2, and the other 3 is going to be for lambda 2. Now, we are also given that there is going to be defects on lambda 1 and 2. So for the lambda 1 is equal to -2 case, we have 1 defect. And so what this pretty much tells us is that we are going to have a chain with a length of 2. The longest possible chain that we'll be able to write will be a length of 2. And so what this tells us is we are going to have 2 ordinary vectors and 1 general, well, technically 3, but 1 non-ordinary vector. And so what I mean by that is when we find the eigenvectors, we are going to have v1, and then the other 2 will be u1 and u2. And so we can see here that this is going to be 2, so our chain is 2. Now for the lambda is equal to 3, we have 2 defects. And so that means the longest possible chain we'll be having is going to be a length of 3. And so we have 2 defects, so that means there's only going to be 1 ordinary and 2 general. And so we are going to have our 1 ordinary, and it's going to be accompanied by the 2 general vectors. Putting this all together, we are going to have our solution written as x1, 2, 3, all the way to 6. They're all going to be with respect to t. And so we are going to have, for the lambda being -2, we are going to have 3 solutions, 1, 2, and 3. Space them out. And so the first one is going to be with v1. And so this is going to be our constant c1 raised to the e, or times e raised to the -2t times v1. And then our second solution will be c2, e raised to the -2 times u1. So far so good. We are writing it as usual. And so like I mentioned, we'll have 1 general vector. So this u2 is our general vector. And then for the lambda equals 3 case, our w2 and w3 is also our general vector. So to write this third solution for lambda equal to -2, we will have c3 multiplied by e raised to -2 as usual. And now we are going to multiply this all by u2 plus t times u1. And so now for our lambda is equal to 3 case, we are going to have x4, x5, and x6 And so our x4 is going to be the same, similar to x1, nothing usual. C5, C5, C4 times e raised to 3t, because now we're dealing with lambda is equals 3, multiplied by w1. And so now for our fifth solution, we're going to have something very similar to our x equals, or x3. So it's going to be c5 times e to the 3t times w2 plus t times w1. And then our last solution would be c6 e raised to 3t. And then it's going to be somewhat similar to the fifth one, but we're going to have our w3. So we're going to start with w3 plus t times w2 this time. That's terrible, w2 plus t squared over 2 factorial w1. And so we are pretty much going downwards. So it's going 3, 2, 1, and then 2, 3, 2, 1, 2, 1, 1. And then this one's 2, 1, 1, and then the new vector. And so yeah, that is how you write the solution for matrices that will have defective eigenvalues. In the next video, we're going to go deeper into this and actually solve an actual matrix, finding the eigenvectors, and then, or the eigenvalues and eigenvectors, and then finding our solution. So hopefully this gives you a little bit more confidence in dealing with these, and hopefully you have like a better understanding when we actually start doing the next ones. So I'll be seeing you guys in the next video.